All right. Thanks, Delaney. Welcome, everyone. My name is David Sullivan. I'm a management analyst principal with the College of Health Solutions. And as you can hopefully tell from my session title, the intention today is to provide an accessible introduction to SQL, usually pronounced SQL. It helps that, at least I think, that SQL is among the more intuitive technical languages you may endeavor to learn. It is certainly among the most important for someone who wishes to work directly with data. So note that I assume no previous knowledge of SQL or databases. And to be completely honest, I'm really surprised to see 44 people log into a training on SQL on a Friday morning. So thank you very much for showing up today. I appreciate that. So my first couple of years at ASU were actually in business operations. But for the last 4 years, I've been working specifically in analytics. And I started out using visual query builders such as Hyperion and Toad. But over the last couple of years, I've been spending a lot more time writing my queries rather than having them generated in the tool. So before moving on, I just want to say we are very fortunate today to have Delaney Dickerson as our Zoom host. She and I worked together a long time ago. And if you have questions, like she said, feel free to put those in the chat and she'll read them out as we move along. It's fine. This is hopefully an interactive thing. I know that Zoom kind of makes it less so, but it's okay to reach out if you have questions. First thing, a joke, and you'll have to forgive me because there aren't a lot of good SQL jokes. I don't know why, but there just aren't. So the first one, I'm planning to make a film series on databases. I've got the first part ready, but I can't think of a sequel. All right, wordplay, that's pretty bad. I can't see you, but I'm pretty sure it landed poorly. All right, so here's the agenda. In keeping with that theme of intuitive vocabulary, I've broken the presentation down into chunks that build progressively upon each other. The first part is in PowerPoint, but because I think slides are really boring, the rest will take place in a live code editor. What I want most for you to take away is a feeling of empowerment. That is the focus of the final bullet. And because there's a real limit to how much can be taught, how much I can go over in 50 minutes, it's important to always be able to continue learning after today. You know, that's key. And the truth is you're always learning, no matter how experienced you are. So let's get started. So a database is an organized collection of structured information. This is the extent of what I'm going to talk about, really, databases. And what I say would probably make someone who knows what they're talking about cringe. So it's okay. Excel is pretty ubiquitous across professional disciplines. So that's kind of what I want to start with today. And you may have used Excel as a form of database in the past. And if you have, you may have run into these sorts of problems. Excel has inconsistent data types. So how is it handling a date? Is it a number? Is it text? Does it think it's a number? Does it think it's a text? So how it interprets it is different. Have you had an ID, like someone's employee ID or student ID? Is that a number or is that text? And then trying to use those in formulas, it's really inconsistent. Sharing access to a workbook across individuals and kind of managing who makes changes to the workbook, right? Because someone makes a change, you come back in and it's broken. Relating tables across workbooks. So maybe one person has a table that has information and someone else has a table that has information that's related, but they exist in different workbooks, and how do you work those together? And like I said, permissions that go with making changes, but also accessing. And if you've ever tried to open up an Excel workbook with 150 megabytes or something, it's slow and it doesn't work very well. And of course, you can't really easily access this information from some sort of web application or whatever else it is. And so these are kind of things that it's like this, right? It's like this kind of information, but it's better. And that's where the database management system comes in. And it's serving as a layer between the data and the users or the application that's accessing that data. And so you interact with the DBMS to make changes to the data, manage access, and yes, which is the focus today, retrieve data. And there are a number of providers that I list here. There's way more than this here. These are just a few that you've probably seen around ASU. Which brings us to SQL, which is the whole point. It's a language used by most relational databases interacting with the DBMS. So when you hear relational database, think of a series of possibly related tables composed of rows and columns. And I can go back and this should seem kind of familiar. This is not how all databases are structured, but I'm going to go out on a limb and say that it's probably what most of what you will encounter unless you have some specific use case. So here are those words that I think are really intuitive. Select, from, join, where, group by. Okay. Select is where you choose the columns you want returned. So you don't have to return the whole table, right? So maybe you need the name, you need an email address. This is where you put that information. From is the table you want to access. And you can also specify like where that table is. Join, so what are the related tables that you want to bring into your query? And where? How do you want to filter the rows that should be returned? And then group by, how do you want to do your aggregation? Is it the whole query, or do you want to do it within groups? So to me, this makes a lot of intuitive sense, maybe compared to some other technical languages, because I mean, it sounds very conversational. I want to select these columns from this table. I want to filter it where these conditions are met. And then maybe I want to join. I want to join like this, and I want to group by according to these groups. So that's where we're starting here. And these are the things I hope you take away today. Before we start querying real code, let's start off by writing some pseudo SQL against our Excel table from earlier. Now, assume that this table is called demographic, and it exists in the main schema. Now, these names are completely arbitrary, made it up. I know I haven't yet defined table or schema, but for the purpose of this presentation, it kind of doesn't matter. You just really need to understand that schemas are a way of organizing objects in the database. Think of them as folders, and you can think of tables as the collections of rows sharing those same columns. Now, when you hear table within the context of a relational database, at least, you can more or less think Excel sheet. The goal in this example is to return a list of female individuals from the table that includes ID, first name, and last name. Let me get my zooms in my way here. Okay, so in the from block, we're going to start there. We are identifying the schema and the table we want to access. So here we have from main.demographic. So we're saying this is the table you want to access. Main is the schema where demographic is organized, and demographic is the table. And you can kind of read that period as saying like access within. So you can access demographic within main. Okay. And that'll kind of go along with the select as well. So what I'm going to next. So select is a section that contains comma-separated list of columns we want to be returned. Those could be columns as they are in the table, or they could actually be a calculated column that is derived from those columns, or it could be something completely custom. So if you look here, we have demographic.id, comma, first name, comma, last name, no comma at the end. It won't like that. So here we have demographic.id. So we're going to access the ID column within the demographic table. So that's important, especially if we have like multiple tables here in our query where like the same table name exists in both. It's not going to know that I want the ID column from demographic, but not from the employment table. So it's important to tell it which table our ID is associated with, or whatever that column is. My cat's jumping on the table. Okay, and then the where section contains logical tests, that is operations we want to conduct, which either return true or false, and those determine the subset of rows that should be returned. So only expressions that evaluate to true are returned. So in this case, where demographic.gender equals female. So again, we're here referencing a column that's gender, that's within the demographic table. And we're saying it should equal female. And you'll notice here that female is in single quotes. That indicates that we're telling it that this is text. So rather than some sort of identity of the table or column or something. So anytime you have like the string here, we're going to have that in single quotes. So as we go through this list here, you'll notice I've already highlighted the blue section. Those are the columns we've said we want returned. We don't have to return the columns we're actually filtering on. We can return any ones we want. They don't have to overlap. So here we look at the first row. Camilla, does her gender equal female? Yes, it does. That's true. So it's returned. Next, Adrian, does that value equal male? It does not. That's false. It does not return, and then so on and so forth. So that's the basic beginnings. So I gotta move Zoom again. Okay. So I also want to talk briefly about aliases and code formatting. So an alias is a name that you temporarily superimpose on the actual table or column name, and that alias only exists for the duration of the query. Table aliases are going to be useful when you want to avoid writing really long table names over and over again, or if you need to use the same table multiple times in the same query, then you'll need to differentiate between your references to that table. And it's also just good practice and will usually improve readability of your query. However, you'll need to balance brevity with readability. For example, here I'm aliasing demographic to the letter D, which is easy to write, just one letter, and doesn't get in your way when reading. But if I had multiple tables here that started with D, then you could start getting confused if one was D and then one was D2 and another one was D3. So, you know, you might end up changing what your mind later on, depending on how complicated your query gets. So I'm going to go ahead and, let's go back. So let's take a look at where this aliasing is occurring. So let's look at our main, our from section again. So from main.demographic. And then there's a space, and then the alias we want to assign to that table. Here, like I said, I'm using D, and then that means you do your table space D, and then everywhere else in your query, you can now reference that table as D. So instead of writing it out every single time in my select and where clause, I now have D.ID. So when we do .ID here, we're saying access the ID column from D, which is an alias of main.demographic. The same goes for references within the where section here. You'll also frequently find that you want the resulting column name, not just the table, to be something different than what's in the database. And you can do this with the as command. And if you want to force certain casing or include non-standard characters like a space, which you often won't want to do anyway, but you can do that by using double quotes. So here, ID, D.ID, it's being returned, it's going to be returned as the name that's in the database, as it is in the table. And then the second one, first name as first in M. So instead of writing out name, this one now abbreviates name to NM. And so the name in the table still going to be first underscore name written out. However, when the result of that query is going to say first underscore NM. And that could be, you could name that first cat if you wanted to. It doesn't matter. You can name it anything. And then the next one, last name as, and then notice that it's not in single quotes here, like it is when we're trying to filter on the string in the table. Here it's in double quotes. So this is saying that here's the name that I want. This is the column name I want returned with the result. And by putting it in single quotes, we can force the result to have the casing we want, and we can include that space. Like I said, you often don't want to do this. Maybe if like you want to, this is going to be like a report you're just going to export to Excel and send to someone, then that can be helpful. But like if you try to use this last name with that casing and space as like a feeder to like another part of the query or something, it's not going to work very well. It'll just create a lot of extra code for you. And an interesting thing about SQL is that it generally doesn't care about casing, like I said, unless it's in those double quotes, spaces, or tabs, except when we're talking about, again, quotes. I mentioned this because it opens up an opportunity to structure the code in a way that's more readable and easily fixed when broken. So here I have, my different sections organized, select from where, so you know what each section is doing, and I have it aligned. Each column name is aligned and tabbed to the right. And so it doesn't care that there's spaces there in the tabs. In fact, if you wanted to, you could write this on one line, and even a query that's, 1,000 lines long normally, you could write that on one line and it won't care. So this is about readability.
So real quick question related to what you're talking about and readability. So Jenna Graham asks, there are no quotes around first name. Why?
First NM.
First NM, sorry.
Yeah, so that's because there's nothing like inherently unusual about that name. There's no space. So like if you had a space there, it wouldn't know that the first and the NM are the same thing for one, right? Because it would say first and then space, and then what is NM referencing? Because it's going to think, are you missing a comma between that? Is that a table? Is that the name of a column? It's not going to know you're talking about the same thing. And in first NM is also going to just return whatever the default casing is of the database. So if we're talking about Oracle, typically that's all caps. If we're talking about Postgres, typically that's lowercase. So it's just because there's nothing unusual about it. So we're just kind of letting the database handle the casing, and it's clear that that's all part of the same reference. That's all one alias. Okay. And one more thing before I move on. So here I've added another complication to our where statement. So we still have d.gender equals female, so that hasn't changed. However, we've added a like statement. So here's another one of those things. This is like SQL's full of all these things that just make intuitive sense. So last name is like C %. And then again, this is in single quotes because what we're talking about is a pattern of strings. So a string is in single quotes. C % means our string starts with C and then ends with whatever. So you could also do %C, and then you could say our string starts with whatever and then ends with C. So you can read this particular expression as last name starts with C. And this could be even CA, and then you could go from there. But that's the new thing we've added here. So as we go through our rows here in our example sample table here, we have the same gender equals female, and I've gone ahead and checked those off again. However, between these two statements is an and, which means that both of these expressions must evaluate to true in order for the whole thing to evaluate to true. So even though Camilla would evaluate to true as being female, her last name does not start with C, so it is not returned. When we go to Katie and Kelsey here, they do both have a gender that would evaluate to true for being female. And they also have last names that begin with C. Now, as I mentioned before, if we had changed this to CA in our like statement there, then only Kelsey would be returned because Crawford is CR. And we also notice here that Bruce Cole, he does have a last name that begins with C, but does not have a gender attribute that would equal female. And because of that and, where they both need to be evaluated to true, he would not be returned. All right, I've added another complication to our where statement here. And you'll notice that among a couple things, right? So one, our conditions from the last example are now, one second. Our conditions from the last example are now within parentheses. And so those statements will be evaluated as a chunk. And then after the parentheses, we have an or, and then a new condition. So both sides of that or will be evaluated. So either one of them is true, and if that's the case, then the row is returned. If they're both false, then it is not. So we only need one. They both can be, but we only need one for it to be returned. And the stuff that's inside the parentheses is evaluated together. So because that's an and, they both have to be true for that to evaluate to true. So as we go through the same information again, we have our like, that the last name is like C, so it starts with C, and we have the gender equals female, so we have the same conditions, and I've gone ahead and added another column here for age is greater than 27, which is our condition that we put here in the pseudo query. So in this first example, we see that Camilla, her last name does not begin with C, but she is female, so she meets one of those two criteria that's in our parentheses. However, we need both of them to be evaluated to true in order for that section to be true, but ultimately it doesn't matter because we have an or between the parentheses and our final condition. So because the age is greater than 27, Camilla is returned in this example. Katie and Kelsey are returned again, like as before, because their conditions within the parentheses both evaluate to true. And if we go into the Heather here, she only meets one of the conditions, and both within the parentheses need to be met. And then finally, these last two examples, Bruce, again, he's got that last name that begins with C. He's not female, so the left side of this expression that's within the parentheses evaluates to false. However, the age for both of these last two rows meets the criteria. So you can get very specific about the logic in your query by adding parentheses and ors, but it can get a little complicated. And generally, you will not be working with only one table. And this is where joins come in. I think maybe occasionally if you have a really nice view that has all the columns you could ever need, but typically you don't. Maybe you need a name from another table or some other information. And so that's the importance of joins. This is what that join looks like between these two examples, two fake tables. And you'll notice, let's see, so let's look at the query here. That's what we're going to do. So this should look pretty familiar, except now we have our main demographic D. So we're aliasing demographic to the letter D. And now we're doing an inner join. And so an inner join is a type of join, and we'll get to that. And the table we want to add to this query is main.employment. So they're both in the same schema. That's arbitrary, it doesn't have to be. And we're aliasing that table to the letter E. And then the last part I want to point out is that now we're doing a where filter, a clause in our where statement that's going to filter those rows to where E, which is a reference to the employment table, where E.salary, the salary column, is less than $150,000. So the employment table here, I've already got kind of sorted from smaller to bigger. So we can see that the first 5 rows are highlighted. And then the corresponding other rows in the demographic table are also highlighted. And you'll see that, in this particular case, and this is something that's kind of specific to the inner joins, that this case, the join is acting as a filter in the rows in the demographic table. So we wouldn't even really need to bring in the salary column if we didn't want to. We could just take the columns from the demographic table, but we would still be getting a subset of the demographic table that meets our criteria, which is that the salaries are less than $150,000. Oh, and I did miss one thing. So the last thing I wanted to mention that's pretty key is that we have this on, right, keyword here, on, inner join employment on. So that's where we're telling the DBMS how we want to join our tables. So we're saying that we have this key that's common to both tables. So in the demographic table, we have an ID key for this person, and then an ID key in the employment table. And these keys, like a 1, references the same person in both tables. And so when we have d.id equals e.id, we're saying that the ID column within D is equal to the ID column within E, so demographic and employment. And that's the logic it's going to use when matching up our tables to run our query. So I stole this from the internet, obviously. And there's a lot here that I think isn't super necessary. So up here but we'll just look at the ones that I think are important right now. So the one at the top here is the one we just looked at. So that is that we have 2 tables, and what's returned is the stuff they have in common. Things that are in A, but not B, and B and but not A are not returned. And then on the left here, the left join, in that case, if we used that sort of join, then we would return everything they have in common, and then everything from the left table. And by left, I mean the table that's, comes before the table we're joining in. It doesn't matter what order you put the on keyword, right? You could flip those and it wouldn't change it. That's not what it's talking about. And then in the right join here, we're doing the exact same thing, just the other way around, right? So if we're using a right join, we're saying, I want to take everything from the table I'm joining in, and then those things that it has in common with the left table. And then the other thing I want to point out is a full outer join. So that's kind of like a special one. It would depend on what you want to do, really. But in that case, you're going to take everything that the 2 tables have in common. You're going to take the things that A has that B doesn't have, and you're going to take the things that B has and A does not have. And in those cases, you're going to get a lot of nulls because it's going to have a lot of stuff potentially that's not in common, but you'll get everything that's in both tables. Okay, which brings us to the example stuff, which is cool. All right, so in this example, I'm using SQLite instead of something from ASU, only because I didn't know if it would be great to put student data up here in a presentation. And plus I can kind of simplify things to maybe more basic level by just watering it down to just an example set of tables. In this example, I'm not really using all of the ones here. We're just really looking at invoices, customers, and employees. SQLite is kind of special because I don't need a server or anything. I can just run it off of essentially a file on my computer. That's why I'm using it. But it's still pretty full-featured for something that's small. Okay, so let me go ahead and stop share for a second while I change my screen.
While you're changing your screen, Nancy Reisner posted in that she loves that slide. So
awesome. Thank you. All right. Hopefully this is. Can you see my my screen here? Awesome.
Looks good.
Awesome. Okay. So as you can see, this is just a text editor because I'm trying to strip this thing down to as basic as possible. What I'm able to do here, the only thing that makes this particularly special is that I can run my query within my text editor. So that's the only thing special going on here. If you're using this in like a production way, which you probably will be if you're going to actually use this, you'd probably be doing this on like Amazon Workspaces and maybe in dbeaver or something like that, which I think that is the preferred tool these days. So the first thing I want to look at is this select asterisk the star from customers limit 20. Okay, what is that doing? This star here, is asterisk, it's kind of a wild card for our column name. So it's saying select everything from the table. If we have multiple tables, it'll select everything from across all of those tables, and it may get kind of messy because maybe those tables have things in common. Honestly, don't use this very often because it's not very useful unless you know exactly what you're trying to do. So in this case, I want to get kind of like a short a look at what this table looks like, and then we can share it. It makes it easier to make decisions about how we're joining things and querying. I also have a limit 20 here, which is saying select everything from customers. And if I just run this, it'll return all customers, which could be a really long list. But adding limit 20 is going to say just return everything from customers, but only return the first 20 rows, which is what it's done here. So here's what our table looks like. We've got a customer ID, names, company, like this looks like some address information, email, and then the support rep that's associated with the customer. So the goal I've kind of set for us in this first exercise, and by the way, I don't really think we'll be able to get to all of these. We'll just keep going until we run out of time. All right, so the first one is create an email list from the customers table that includes both North America, that's USA and Canada only, and use an in keyword and then label the region. Okay, so let's go ahead and comment that out, which brings to the first thing I want to mention, that you can comment things in SQL. So if you want to comment out a block like I have done here, you do a /* and then an asterisk /. So just the stars are within the center. That's the thing you want to remember. And then everything within that block is excluded from what consideration in the query. It's going, you're going to send it to the system, and it's going to just disregard that because it's part of a comment. And that's something that would go across multiple lines in your query. The -- here is going to say that everything in this line. So, you know, the stuff I write right below it is still going to be considered, but the -- is going to say, ignore this for now. So what I'm going to say, it's a pretty common way for me to do it is if I kind of usually am going to start with the key parts of my query. So I'm going to have my select. I'm going to have from, and I know I'm going to have a where for sure. So I'm going to select from, and that's going to be customers. And let's go ahead and alias it to C. So I've done the customer space C. Now everywhere I say C, it's going to know I'm talking about customers. And since this is an email list, I'm probably going to want C.firstName. I need my comma. C.lastName. By the way, there's something funny about SQLite too, that it lets you do this camel casing. That's interesting. You're not going to see that really, I don't think, anywhere else at ASU's data warehouse. All right, and then let's do email. That's what we're talking about. Oh, we'll do country as well. So C.email, and let's do C.country. Okay. So we have our columns selected. So this is the subset of columns within our select statement. These columns, the subset of the table, will be returned in our query. In the where clause, the where statement here, we want to return only countries that are USA or Canada. Now, really, there are two ways of doing this. We want to say that C.country is equal to USA, or C.country is equal to Canada. All right. So this will return, so if they equal USA, return those rows. If they equal Canada, return those rows. And then if we keep adding more and more, we want Canada, we want Brazil. Maybe if we keep doing this, then this gets kind of long. And we're really duplicating the code here because we need to say, you know, the name of the column and then what sort of condition we want it to test, the name of the column, what condition we want it to test, and each one is separated by an or. We can simplify this by saying, let's put that back, by saying instead of equals in. And this is another one of those really cool things about SQL, right? In makes sense. They're saying that we want to return rows that meet this criteria for this column by being in this list of strings. Okay, that seems really intuitive. So we want to return rows where country is in this list. So you do that by having your parentheses and then a comma separated list within there. So this is a string, so each one, again, is single quoted. So I think we can run this, and there it is. And that's what we wanted. We now have our first name, last name, email, and then a subset of the table that only has those customers from Canada or USA. Any questions on that one? Okay, so moving on to the next exercise. Okay, so we know what customers looks like. We saw that in the last example. I've added something else here, a new starter query. So select distinct country from customers. So really the difference here is, one, we're just looking at one column. And I've also added the distinct keyword. So the distinct keyword is going to say that it's going to go through the results that are returned, and it's going to only return unique rows. So it's going to say that this combination of rows is unique. Since I'm just looking at one column, it's saying that that each row has a unique country. So it's going to go through and say, here's a new country, and then toss out all the other duplicate references to that country in this case. So what we end up with here is a unique list of countries in our customers data set. Let's go ahead and comment that one out and then uncomment this. So this is what we ended up with. Oh, I missed one. Yeah. Okay, but well, it's fine. Okay, so one other thing I didn't show you in the last example is that you can also write in things into your select. So let's just show you what that looks like, because I didn't do it. So what this is going to do is just put North America in every row. Now that's kind of like useful in like a small number of cases, but like if you have multiple queries and you're like unioning them together, you can label which part of like, you know, your query is ending up in your final results. That's a bit much right now, but you can do it.
So in some of the description, one of the questions, so you have the country and in. When you get a second, can you show how you might create an or and an and? Sorry, and an and. Oh. Yeah, so an or this and this. So there are times when it's not an in, like you only want just these two. In is best if you're saying, I know I need these sections. I need this group and this group and this group. Instead of adding a bunch of and statements or statements. But what if you needed to do this or this and this and this? What might that look like?
Okay, let's think of a different situation. So actually, let's put that back. Or what's something we can do? Or let's say, I don't know, what's a good example? I don't. There's not a lot of good columns in here, but let's say, let's just say, for example, just to show you what it looks like, that what we want is it's in these country codes in these particular countries, or we're saying that the last name should end in or something. Or let's see, this is Kara she's from Denmark, so that works out. Or c.last name like, and again, that's in %. Hang on, I'm getting like notifications. Okay. And so now we see Denmark in here. So it's going to say, so what this is doing is it's saying country equals USA or country equals Canada, and then or last name equals is like and. If we change this to and, which I think was the question, we're going to get nothing because nothing has a row. None of the rows have a combination of being country equals USA or country equals Canada and last name beginning with N. Yeah, so that's what's happening here. Is that what the question was?
Yeah, so I think it's kind of what do each of those types do and why, you know, that kind of as a repeat. What does in do? What does and do? What does or do? And how can you use them in combo?
Yeah, so again, when you see in, you're just going to read what this is really doing is we're saying that this condition right here, it's just saying each of those is really an or. And so as long as country meets one of these criteria, it's going to return true, essentially. And both of these sides are separated by an and, which means that this side needs to be returned true, and this side needs to be returned true. So while this one is composed of ors, where only one of those conditions need to be met, the and in the middle means that one of those conditions needs to be met over here, but we have to meet this condition over here. So depending on your combination of parentheses, whatever.
So for example, let's say you were looking for the country, whereas in USA or Canada, but maybe you also want to find any other countries that start with CA. So you could say, or the country like CA, because you know that you want to hit that range, and that gives you a wider. You could also do and like CA, and you're going to get the same results because it's the conditions are and is more it has to meet specific criteria versus or where it's like, well, it can meet this criteria, or it can meet this criteria, or it can meet this criteria. So thinking of it like that.
All right, let's.
Hoping that answers, Jenna, I'm hoping that answers some of your questions.
Yeah, we're definitely not going to have enough time to get through these. Okay, let's see here. Let's just keep going on for a little bit longer here. So we have that same email list, and we're going to add a case statement here, because rather than just writing in North America here, we're going to actually say, we're going to go ahead and give all of these countries a label. So we'll go ahead and remove this here, and let's remove this altogether, because we're just going to look at all of the customers. And so we'll use a case statement. So that begins by writing case. And then there are two patterns to a case statement. You can either do a case where, and then you'll have a condition and then what you want returned, or you can give it the column case with this in this case, So again, something intuitive, c.country. And then we'll say where. So for each instance of country, we're going to see if it matches this pattern. So where the country is Canada, then return North America. Okay, and then we can keep doing the same thing, where USA, then again, North America. Okay, so I'm not going to keep doing all these because there's a lot of them. I actually have it already pre-coded here. And then the last thing you want to do here is else. And so this is what you want to return if none of your conditions are met. We could say like null, in which case it'll just come in blank. We could give it a dash, which is maybe a cue to us that we're missing a value. So whatever you want, and then end, and then the name. Now it's an as. So, and then this is basically the name of this computed column. So it's going to run through each of these. So let's go ahead and just throw these in here. Case. Right, so I've gone ahead and assigned each of these countries a continent, basically. All right, else. Let's just give it nothing, end as region. All right. Okay, so now we have our email list, we have our country, and we've assigned each of these to a region. So it's looking at the country, and it's giving us a custom column. that uses this logic to return the region for us. Now, one thing I noticed, maybe we can use the else section in this case to simplify this a little bit, because there's a ton of Europe options. And then if we do that, we get the same result. It's just going to assign all those ones that don't have a value to Europe. Okay. Any questions on that? Oh, one other thing I wanted to show you is that this other pattern. So case when c.country equals USA, then so what you're going to do is you can have c.country and name equals this, and then we have whatever you want to return, North America, and then when we can have c. Last name, so we can have like, oh, I'm butchering it now, right? But we can have like completely different logic in each section, and then so the first block of expressions that evaluate the true will return the value. So you get more really fine-tuned logic to how it's evaluated and what value is returned. How are we doing on time? Got 3 minutes. Well, okay.
I think we have until just before 10:30. So.
Okay, we'll keep going one more, I guess, then, and then I'll have one more final thought. Let's look at invoices.
And real quick,
the invoice
question about, would you mind showing how you would get SQL Query to run inside Sublime? Or is that outside the scope of this presentation? And I think it's outside the scope right now, right, David?
What's the question again? Sorry.
Would you mind showing how you get SQL to run queries inside Sublime?
Oh, that's kind of outside the scope of this. And Sublime's not on. This is just on my computer, so it's not going to be on. Probably not on the workspaces anyway. So
there's a couple extra.
If you want to reach out to me, you can. And I can tell you how to, and you can practice it yourself. But yeah, it's a little outside the scope right now.
So there's a couple extra questions. Jenna also asks, just from a commenting out perspective, any of the items between the // with the stars in between, asterisks in between, it's just a note to self and stuff in between, where hyphen and actual's part of the query. So SQL recognizes when you put a hyphen as blocking anything past it in that line of code as a comment out. And then Becky Loomis asked the question, would case work the same as decoding a field?
Yeah. I mean, it's not written the same way, but I mean, if that's what you're used to working with it, yeah.
Oh,
yeah.
okay.
I mean,
gotcha.
Yeah.
Sorry.
I mean, I'm guessing that's like, is that a reference to like Hyperion?
Yeah, I'm not sure what's meant by decoding field. Benjamin, or maybe you can expand on that. But also, Jenna asked, not sure what comments out means. So.
Yeah, I can go ahead and take that. So yeah, in this case, so you can use it to like tell it to just ignore parts of your query as you're working and debugging things. Yeah, so it's just saying to ignore it. You can also use it to like say, to talk to yourself later and maybe your colleagues and say that this segment of the query uses such and such logic because so-and-so told me that this is how it's supposed to be done, or, that this is the brackets I was told that this, student financial criteria should be met. It allows you to talk to yourself later on as well. Or maybe sometimes I have really long queries that are a combination of 50 subqueries because it's going into this big retention workbook. And then myself later on next year when we're doing this whole process again, will say, what was this subquery doing? And then that can be very time consuming. And so you can go ahead and give notes to yourself saying that this is what it's doing. Maybe this is why I did it this way.
Right. And Jenna says she understands now. Just ignoring the section that you're trying to run a query based off of, so that you have either notes, or you can ignore part of the query so that you can see what the other results are, those kind of things. So Becky wrote, letters in a field that just have the letter to decode its meaning. Instead of V, you can use decode that to vacation. I'm not familiar with decode. I think that's particular to.
I want to say that's a Hyperion function.
I think that's a Hyperion function, yeah. And Jenna also asks, as we're getting close to the end of the time, David, can you do a series of workshops?
I know. It's tough to do so much in one session. I did ask for 2 hours, and they're like, we can't give you 2 hours.
Yeah, yeah. You know, there are some SQL workshops, so everybody knows, through Career Edge. So when you go into My ASU, it used to be lynda.com, and we've partnered with them. There are some query, how to write SQL tutorials there. Yeah, as well, just as a side, there's some online and there's some on YouTube. Somebody also asked, is there a sample earlier on? Is there a cheat sheet with all the code snippets? And there's a bunch online. You can Google it, SQL cheat sheet, and you'll get all kinds. So there's definitely out there.
Yeah, there's a lot.
All right.
All right. Let's do one more, and then we'll go ahead and finish up. Okay, so we've got invoices here, and we're gonna because I want to make sure we do at least a join, right, before we finish up here. So here's what our table looks like. We'll comment that out, so it's no longer gonna look at it, and we're gonna uncomment this section. And so this is what we started with. This is what we ended up with in our last example. Ultimately, what I want to end up doing is let's go ahead and look at that, what that looks like. What I want to end up doing is bringing in the amounts of the invoices, and then we're going to ultimately want to just see how much revenue is coming in from each region. So what we need to do is actually, I want to be able to, here, I want to look here, table. Let's bring in invoices one more time. So this is what the invoices table looks like. You know, if you look into dbeaver or something, then you're going to be able to see what those columns are, which is going to be helpful. Anyway, so let's go ahead and do our left join, because we want to make sure that if some of our customers don't have any invoices, we still want to see that they have maybe a 0 return. So we'll do a left join and then invoices. And let's just alias that to I, and then on. And then let's say we need I dot, it's going to be customer ID. We can see that here. And then the other side here is going to be our left side of the join. That's customers. That's C dot, I believe this is employee ID, but I don't remember. So let's look at that too. We need, it's actually customer ID. Both sides are customer ID in this case. Okay, that's handy. So let's go ahead and run that. And you'll notice that it's just duplicating rows for us, because what it's doing is it's our employee side, or our customer side, is 1 row per customer. But our invoices side is 1 row per invoice. We'll go ahead and bring in a column from the invoices table. So that's I, because that's what we aliased it to. I dot, I believe it's called total. So let's run that. So now we see that this is the total for each invoice. Yeah, let's do one more because this last one's pretty easy. Let's just take this and then find the total. All right. All right, so we have first name, last name. We want the total by total sales. Okay, let's do by country here. So let's just take this off for now because this will make it easier and at a time. Okay, we don't need first name, last name anymore because we just care about country. We still want our join here. We need a comma here, otherwise it'll get mad. And what I want to do is I want to do a sum. So this is just a function that's common to a lot of databases. And if I run this, it's going to say Brazil 23286. And that's because it's just grabbing arbitrarily the first instance of country and then summing all of the totals. But I really want to see the total by country. And you can do that by giving it a group by. And this means it's going to do a sum within each group. So we want to group by c.country. And if we have multiple columns, we need to put each non-aggregation column in this list. And it's a comma separated list like select is. So now we get a sum for each one. And so one thing I wanted to show is that I think there's a lot of emphasis on Python or R, but you can do a lot of analytics just in SQL. And sometimes it makes a lot of sense. You don't need to pull a lot of data back from the database, and you can do some of those things in database. So given where we are time-wise, I'm going to go ahead and stop this part. But one thing I did want to mention is that hopefully that this is helpful for you as a starting point. And then as you go forward, where is my Zoom? There you are. So as you go forward, Google is your friend. Delaney mentioned a lot of good resources there on Career Edge. But if you get into a bind, maybe you're writing a query in Postgres or something on the Aurora user database, and you're like, how do I extract something from a string? Well, all you have to do is just go to Google. So we're going to say Postgres string functions, okay? And then here's an example. And we have documentation here from PostgreSQL.org, and they're the ones that run Postgres. We'll look at the current version here. And then we can look through all these functions. You may not know off the top of your head which one you want, but you can read through these until you find the one you want. And maybe it's this one, substring, where you start with a string and you tell it, which part of the string you want returned. So there's so much on the internet as far as trainings and these documentations. I would try to get comfortable looking at technical documentation because it's going to be your friend, even though it can look kind of intimidating. I'm happy to take any questions.
We have about 1 minute and then
showing up.
Yeah, thanks everybody. So we have about 1 minute and then we're going to have to we're going to end this and hop over to the end session. So everybody's saying thanks for the session, and absolutely, Google YouTube is your friend. It's my friend every day. I can't tell you how many times, even as a technical resource, I'm like, oh, what was that one? I need to look it up, and I can't remember the words, and I string words together, and there it is. Look through a couple different pages, so it's a great resource.
All right, thank you.
Thanks, David, for a great presentation. Thanks, everybody, for wonderful questions.